out and sharing my screen. So today's the 29th, homework 2.3, which is just finding the equation of the line. That point slope formula is due today. Homework 2.4, which is more on slope, is due on Wednesday. Exam 3, just if anybody's really forward thinking, exam 3 on will be April 9th. So oh dear, they're getting all. Go ahead.
Yeah, I'm just wondering if my math lab is lagging for anybody else. I feel like the website's being a little glitchy today.
I know that it was last night. Last night, I crashed early, and when my husband woke me up off the couch to go to bed, I had a couple of emails that people had sent me right around 10 saying that they couldn't get into my labs. And so I immediately went and checked to see if I could make adjustments for them, and I couldn't get into my labs last night. So I have not had problems with it during the day today, but I do know that I got an email from one of my coworkers asking everybody in the department if my labs was down for us. Hopefully it'll be because there were problems last night and people were saying that they were having issues with quizzes. I left the quizzes that were due last night. I made at a time so that if you did not do your quiz over the weekend, you need to get it done before midnight today. If it's a problem with the homework, send me an email, and rather than changing the due dates on the homework, it's much easier for me to take away like late penalties if the cause for being late was beyond your control. So
Okay, I'll keep giving it a try, but I gotta head to work after this.
yeah, all right. Well, hopefully you got that quiz done
Yeah.
before 9 o'clock Sunday. So all right, we left. Oh, I'm a jerk. Before we pick up with the notes, does anybody want to look at any homework questions?
If I can get in, I probably would.
Which homework, 2.3 or 2.4?
The one due today.
Okay, that's 2.3. And let's see if it lets me in. If it lets me in, it should let you in because I don't have any magic powers. The other option, yeah, it's saying that it's not liking me. The other option is in that homework that's due today, which was 2.3. I did upload PDFs of the homework for people who lost their MyLabs access. So I can look at them this way. It's just a worksheet as opposed to the interactive problems. Do you remember about where you had questions?
No, it's not that big of a deal. I can probably pick up with it when it comes back on. So
And again, don't be afraid to use it. Ask my instructor button.
Sure.
Okay. Anybody else want to look at anything else from the homework? Because again, these are the same questions, just a slightly different format. Not hearing any. Last class, we were talking about slope, and we had looked at the point slope formula for a line, which is y minus the y value is equal to the slope times x minus the x value. We had looked at the slope intercept form, which was the y equals mx plus b. Remember, B is the y-intercept. We had the general form of a line, which was ax plus by plus c equals 0. We had the slope formula, that the slope is the difference in the y values over the difference in the x values. And I don't think I ever told you guys the lame way that one class told me was a way to remember. The y's are in the top and the x's are in the bottom. It's very lame. It's politically incorrect. But it was decided by the group that everybody wants to vary their x. And so the x's are in the bottom, never mind. We also looked at the idea that if we had parallel lines, they had the same slope. Instead, we said if we had perpendicular lines, we had to break into two cases. First case was that a horizontal line which has a slope equal 0 is perpendicular to a vertical line. Which does not have a slope. The slope is undefined. And if lines are not horizontal and vertical, the other case is that if I have slant lines, if they're perpendicular, the slopes are negative reciprocals. They have opposite signs, and you flip the slope, you take the reciprocal, the fraction. And so we had said examples of negative reciprocals are A over B, and the opposite would be negative, and the reciprocal would be B over A. And so you have to both change the sign and take the reciprocal. And I think that was exactly where we left off last class. Is everybody with me with all that stuff? Are we all good? Not hearing any concerns then. I'm going to add a page and add a couple of examples that deal with that last concept. We're going to find there are two types of problems that you might see with perpendicular lines. One might be where you're given two lines and asked if they're perpendicular. So let's see, whoops, let's try that again. Let's see, are the lines with equations y equals negative 3/4 x plus 8 and 4x minus 3y minus 12 equals 0 perpendicular. And I think last class, I had said that when I hear that word perpendicular, just like when I hear that word parallel, both of those words make me think that I need to know the slope. And so if I look at that first line, y equals negative 3/4 x plus 8. Because it's solved for y is alone, I know it's in my slope intercept form, y equals mx plus b. And so the slope is that x coefficient, or negative 3/4. For my second line, 4x minus 3y minus 12 equals 0. To find the slope, I want to do that. I want to solve it for y. I want to put it in that slope intercept form. So to get y alone, I'm lazy, I only want to move one thing, so I'll add 3y to both sides, giving me 4x minus 12 equals 3y. And then dividing by 3, I get y equals 4/3 x minus 4. Now that it's solved for y, I can compare it to y equals mx plus b. And I see that here, my slope is 4/3. And so as I look, they are definitely different. So they would not be parallel. But does everybody see that these indeed are, one's positive, one's negative, so they have opposite signs. And 3/4 and 4/3 are inverted, so they're reciprocal. So my answer here would be yes, the slopes are negative reciprocals. Yay, we got it. Thoughts? Is that problem all right for everybody?
Yeah.
If there are no questions, then the other type of problem that we see is it asks us to find or write the equation of a line through a given point, let's say through the point 4, -7, that's perpendicular to the line 2x plus y plus 1 equals 0. And just like last time, the first that I want to do it is I want to get it in slope-intercept form. But then I want to do a little bit of gently massaging it to get that answer in general form. And I think when we see it in general form, we'll find a shortcut, just like we did for parallel lines. But again, if the question asks you things like, what is the slope of the given line? What is the slope of the perpendicular line? Again, in order to find perpendicular, I think slope. And so I want to find the slope of this line first. To find the slope of 2x plus y plus 1 equals 0. Again, first thing I want to do is I want to solve it for y. I want to get the y alone. So I'll subtract y from both sides, giving me 2x plus 1 equals -y. And then to get the y all alone, I'll divide both sides by -1. And so I've got y equals -2x minus 1. And so when I compare that to my y equals mx plus b, the slope of this line is -2. And again, I like to think of slope as a fraction. And so I'm going to think of that as -2/1. Now, notation-wise, you sometimes see m with a little perpendicular. And this would be the slope of the perpendicular. And for the perpendicular slope, again, we said it has to be negative reciprocals. To say that it's the negative reciprocal means it has to have the opposite sign. Since this one had a negative slope, the reciprocal will have to be, the negative reciprocal, will have to be positive. And when I flip 2/1, I get 1/2. And so then my perpendicular line will have a slope of 1/2. And now I have a point So I'm going to go through and I'm going to use my point slope. Because I'm writing big today, I'm going to get rid of this general form, and we'll do that a little bit further down on the page. The point that we had was 4, -7. And the slope that we're using is this perpendicular slope 1/2. And so when I substitute into y minus the y value is equal to the slope times x minus the x value, I get y minus -7 would be y plus 7 equals my slope is 1/2 times x minus the x value is 4. I need to distribute, giving me y plus 7 equals 1/2 x minus 1/2 times 4 would be 2. And then I'll subtract 7 from both sides, and I'll get y equals 1/2 x minus 9. And so that would be my slope-intercept form of that perpendicular line. And up here, before I distribute it, this would have been my point slope form. But now let's go through and try to put that line, like we had said before, in general form. And in general form, we're saying one side is 0. So to make one side 0, I'll subtract y from both sides, giving me 0 equals 1/2 x minus y minus 9. And I could stop there, but I want to clear the fractions by multiplying both sides by the denominator 2. 2 times 0 would be 0. 2 times 1/2 would be 1x. 2 times -y would be -2y. And 2 times -9 is -18. And so this is what I'm going to look at as my general form. And I want to compare that to the original line. So that's the general form, and it's supposed to be perpendicular. My original line was, I'm going to scooch up here, 2x plus y plus 1 equals 0. So we'll say 0 equals 2x plus 1y plus 1. And last class, when we did something similar to this, but with parallel lines, and I'm going to just scooch back for a minute and look and see if I can find it. We had said with parallel lines, oh, I think I'll go back one more. No. We had said with parallel lines was 2x minus 3y minus 7 and 2x minus 3y plus 13. And we had said that in simplest form, the x and y coefficients were identical. Instead, today, if I look at perpendicular lines, those coefficients are not the same, are they? But does anybody notice anything? Didn't the x coefficient become the y coefficient? Didn't the y coefficient become the x coefficient? And didn't I have opposite operations in the middle? And so the shortcut would be that the line perpendicular to ax plus by plus c equals 0 through a given point, x1, y1 is, and for the same slope, the coefficients are the same. For the reciprocal, we'd have to interchange the coefficients, bx, ay, and because it's not just the reciprocal, but the negative reciprocal, we have to change that operation in the middle. So that gives me bx minus ay, and our point has to satisfy it. So to get the new constant, we're going to substitute those coordinates in for x and y. I'm sorry, yes, those coordinates in for x and y with the coefficients given. So again, the original question asked for the line perpendicular to 2x plus y plus 1 equals 0 through the point 4, -7. Well, I'm going to switch the coefficients. I get 1x, 2y. To change the sign, I'm going to make it negative. And then I'm going to substitute my coordinates. 1x minus 2 times y gives me x minus 2y equals 18, or x minus 2y minus 18 equals 0. So if you're starting in general form and want to end in general form, it gives you a shortcut. But don't feel like you have to memorize that shortcut. Probably the more rigorous way of doing it is to, again, make sure that if I want perpendicular, I have to find the slope of my given line, take the negative reciprocal, and then use my point slope form. Is that clear? Any questions?
No.
Did you want to try another one, or are we good? Let's have you try one. Let's have you guys find the equation. Actually, I'm going to ask you to find two. A line through a point, let's say 2, 6. That's first parallel to, and then second perpendicular to. And let's have y equals 3x minus 1. And with this one, because it's not general form, I would go back to that definition. Find the slope of the given line. For the parallel line, keep it, use point slope. For the perpendicular line, take the negative reciprocal and use point slope. And I'll be quiet for a minute and let you folks work on that. Azim, you're here, yeah.
Yeah.
Tom, did you come in?
Yeah.
And Cameron, I got you. Is there anybody else who came in late? Is there anybody else who got their parallel line through that point to be the line y equals 3x? And their perpendicular line through the point to be the line y equals negative 1/3 x plus 20/3. Are we good, or do you need a little bit more time, folks?
Just need a little bit more time.
Okay. Let me know when you're ready. Or let me know if you have any questions. We good?
Yeah.
Okay. Then if we're all right with slope, equations of lines, parallel and perpendicular, and graphing lines, we're going to switch gears a little bit. And next we're going to look at the midpoint of a segment with given endpoints. For lack of originality, my endpoints are going to be x1, y1, and x2, y2. And again, we're not going to prove or necessarily verify this formula. I just want to justify it to you because, again, I was always the kid that if it made sense, it was more likely to stick. So I'm going to have 1 point here, x1, y1. My other point I'm going to put here, this will be my point x2, y2. And I want to find the coordinates of the midpoint, that point in the middle. When I look for the point in the middle, because it's a point, is everybody all right? It's got to have two numbers. It's got to have an x value and it's got to have a y value. If I tried to picture this being on an axis somewhere, does it make sense that that x value for my middle, if it's indeed in the middle, would have to be right in between my two x values? And the way we can find a number midway between two numbers is to take their average. So the x value is going to be the average of the x values, x1 plus x2 over 2. And in the same way, that point needs to have a y value. And if this is my y1 and this is my y2, that middle one has to be right smack dab in the middle. And to find a value in the middle, I would take their average, y1 plus y2 over 2. And so I kind of think of it almost as being the average of the endpoints, the average of the x values, comma, the average of the y values. So for example, if I ask you to find the midpoint of the segment. We're going to do more than one, so that's segments plural with the given endpoints. And for the first one, let's say we have the points 3, 8, and 15, -2. Again, the midpoint is a point. It has to have an X value. It has to have a Y value. The X value is the average of the X values of the points. The Y value is the average of the Y values of the points. So that would give me 3 plus 15 over 2 for the X value. 18 over 2 is 9. And 8 plus -2 over 2, or 6 over 2 is 3 for the Y value. Instead, if I have the points 1, 7, and 11, 10. What would that midpoint be? That's an uppercase M for midpoint, not a lowercase m for slope. I'm sorry. Average of the X values would be 1 plus 11 over 2. And 12 over 2 is 6. Then 7 plus 10 over 2 would be 17 over 2. And most frequently, they like it better if you leave it as the improper fraction. One more. This time, let's have our point be 0, radical 8.
Excuse me, ma'am. I think in the last example of the slope, I think you made a mistake in the
For the slope,
the last example before this.
for the midpoint or for the slope?
Slope.
Where did I go wrong? Oh, here.
No, not this one. Yeah, this one. The perpendicular thing. So I don't know. You got 20 over 3.
Oh, okay. Let me backtrack a little bit and I'll justify my 20 over 3 to you. Are you okay with the y minus 6 equals -1/3 x plus 2/3 after I distribute?
Yeah.
So now to solve for y, I'm going to add 6 to both sides. But what you have to remember when you add to a fraction, that's 2 over 3 plus, well, 6 with a denominator of 3 is 18/3. And 2/3 plus 18/3 does give me that 20/3.
Oh, now I understand.
The other way you can look at that, if that didn't jump up and bite you on the nose, is the other way I could look at it is 6 plus 2/3 is 6 2/3. And to change the mixed number into an improper fraction, remember you take 6, multiply it by the 3, which is 18, and add the 2, which gives me the 20/3.
Yeah.
Better?
Yeah.
Thank you for asking.
Yeah. I'm sorry for taking you back.
And here, let's have our second point be 10, radical 32. Well, the midpoint, the average of the x's is 0 plus 10 over 2. The average of the y's is radical 8 plus radical 32 over 2. I'll do the hard one. 0 plus 10 is 10, divided by 2 is 5. But over there, can anybody remember what we have to do? I'm going to do some scrap work on the side to add radical 8 plus radical 32. Can I add them as they are?
No.
No, they're not like. But wait, can I simplify them? How would radical 8 simplify? What number goes into 8 that's a perfect square?
4.
4. So that's 4 times 2. The square root of 4 is 2. So that's 2 radical 2. And how about 32? What number goes into 32 evenly? That's a perfect square. What's the largest number that goes into 32 evenly? That's a perfect square.
2.
2 goes in there 16 times. And 2 is not a perfect square, but 16 is. But I like the way you think. We're hoping that they add. So we're hoping there's a radical 2 left. Square root of 16 is 4 radical 2. And so now when I add those, I get 6 radical 2. So that gives me 6 square roots of 2 over 2. And remember, we're going to just divide the 6 by 2. We can't divide the number underneath the radical. So that gives me 3 radical 2. Don't be surprised. You might run into 1 or 2 that involved in the homework. So midnight, all right. Midnight, oh my heavens, midpoint, all right. If so, there's another formula that we need to be familiar with. And that's the formula to find the distance between 2 points. And when I do this, I like to break it down into 3 cases, just because the first 2 cases help me come up with that formula for the 3rd case. And so if my 2 points, case 1, have the same x value, an example might be if I want the distance between the points 1, 2, and 1, 5. So I'm going to take a minute and graph these points. One, 2, and 1, 5. And the distance between them would be the length of the segment. And if I were on graph paper, does everybody see that the distance between them on graph paper would be 3? I could get them because it's a vertical line. by counting blocks. But then I look at those 2 points and I think, is there a way I could have gotten that number 3 without counting blocks? And you notice that if they have the same X value, the distance between them would be the difference in the Y values. Can everybody see that one? So the second case will be if I have 2 points that have the same Y values. And so, for example, I could have the point 2, 3, and 4, 3. And again, I want to try to picture this. My first point is 2, 3. It would be here. My second point is 4, 3. It would be here. And if I look for the length of that segment, the distance between them, well, if I were on graph paper, because it's a horizontal line, I could count blocks. And you see how that gives me a distance of 2. Or I could say when the Y values are the same, I could get that result by subtracting the X values. So that the distance here is the difference in the X values. So if I have a vertical segment or a horizontal segment, I can count blocks, or I can subtract the coordinate that changes. Where it gets a little bit dicey is if the points have nothing in common. Which would lead to me having a slant segment. And so without losing too much generality, I'm going to draw a set of axes. And I'm going to make one point here be x1, y1. And the other point here be x2, y2. And I'm going to take a minute to show you folks the derivation of this formula, because it also, in some ways, would give you a method of finding the distance between 2 points if you can't remember the formula. Because we're going to fall back on something that hopefully you're familiar with, the Pythagorean theorem. If my picture looks like this, I want to picture putting a horizontal line through the lower point and a vertical line to the higher point. And they're going to meet at a right angle. And now this point, because it's right below the higher point, it's going to have that same X value, x2. And this point, because it's directly across from the lower point, it's going to have that same Y value, y1. this segment from here to here, well, they have the same x values, so it'll have as its length the difference in y values. This segment from here to here, because they have the same y values, it will have as its length the difference in x values. And the distance that I'm looking for would be the length of this segment. But to find that segment, what I've got here, I've made a right triangle. And in a right triangle, if you remember, c squared is equal to a squared plus b squared. C is the hypotenuse, which is what we're looking for here. I'm going to use d for distance. And so that gives me that the distance squared is equal to, well, one segment is the difference in the x values, x minus x quantity squared. And the other segment would be the difference in the y values, y2 minus y1 squared. Distance is always thought of as a positive quantity. And so I'm going to go through and take the square root of both sides. But because distance is positive, I don't need to worry about that plus or minus sign. And so that gives me that the distance between 2 points is the square root of the difference in the x values squared plus the difference in the y values squared. And that, folks, is what you need to know and love. This is your distance formula for two general points. And so summarizing, the distance between 2 points my points will be x1, y1, and x2, y2 is given by the formula. D equals the square root of the difference in the x values, x2 minus x1 squared, plus the difference in the y values, y2 minus y1 squared. And again, it's just an application of the Pythagorean theorem. Have many of you seen this formula before? Not hearing any comments, let's go through and let's do an example. Let's find the distance between the points. Let's have the first one be -1, 3. And let's have the second one be 2, 7. Our formula is the distance is equal to the square root of the difference in the x values squared plus the difference in the y values squared. When you do this, be very careful. Remember that when you square a negative number, it becomes positive. So those squares, once we square them, they should both be positive. And so we should never have an imaginary distance. So that gives me the square root of 2 minus -1 squared plus 7 minus 3 squared, which would be the square root of 3 squared plus 4 squared, or the square root of 9 plus 16. Order of operations, we've got to add what's in that underneath the radicand first. So that gives me the square root of 25 or 5. And sometimes they work out evenly, but most often they don't. So this time, let's find the distance between, let's say, 3, -5, and 10, 7. And let's find it in simplest radical form. And then to the nearest hundredth. And I'm going to be quiet and ask you folks to do the arithmetic on this one first. Did anybody else get the square root of 193, which is 13.89?
Yeah.
Any questions on that distance formula? If not, we're going to find that that distance formula helps us, of all things, find the equation of a circle. And we're going to have to take out of the closet and brush all the dust off are skills completing the square. Because in finding the equation of a circle, completing the square is going to be a really useful skill to remember. But before we do that, let's go through and let's look at what a circle is. Has anybody ever used a compass to draw a circle? And when you use that compass to draw the circle, you put the point somewhere that turns out to be the center of the circle. And if you've got a good compass, when you spin it all the way around, what the compass does is it makes sure that every radius of the circle would be equal, or the distance from the center to the edge is always the same. So we're going to say that a circle is the set of points in the plane. And since they're points, we'll call them x, y, such that they are a given distance. That distance is called the radius. So we'll call it r from a given point. Which is called the center. And so here, we're going to have our center be a point HK. And so if I stop and think about it, what this definition says is I'm going to have a point here, that's my center, HK. And then I'm going to try to find every point XY in the plane so that its distance from HK is always R. And wouldn't that definition, if all of these points XYs are R away from the center, wouldn't that give me a circle? And what happens is in this definition, that word distance helps me come up with this equation for a circle. We want the distance from HK to any point XY to be my radius R. So the distance formula says the distance is the square root of the difference in the x's squared plus the difference in the y's squared. But our distance is going to be R. And one x value is just going to be every point x. The other is going to be h, the center. One y value is just going to be y. And the coordinate of the center is k. And what happens is because we want points both above and below, we don't just want the positive distance. So we go through and we square both sides. And squaring both sides undoes that square root, which makes the equation look a little nicer. We get r squared equals x minus h squared plus y minus k in parentheses squared. And this is the equation of a circle, center at some point hk, and radius I. And so that's one of those other formulas that you need to know and love. So let's look at a whole bunch of examples. Whoop. First example, let's find the equation of a circle with center, oh, let's make our center something like 3, 2, and radius, let's make a radius some nice big number like 10. Well, our formula is x minus h squared plus y minus k squared equals r squared. H is the x value of the center, or 3. K is the y value of the center, or 2. And r is my radius, or 10. And that gives me x minus 3 squared plus y minus 2 squared equals 10 squared. And most often, we want to leave that variable side the same, x minus 3 squared plus y minus 2 squared. And on the other side, where I square 10, I get 100. So next one, let's have our center be, oh, let's give it negative coordinates. -5, -6. And let's have our radius be a small number, let's say 2. And the formula is x minus h squared plus y minus k squared equals r squared. H, the x value of the center is -5. K, the y value of the center is -6. And r, the radius is 2. So x minus -5, well, that would be x plus 5 squared. Y minus -2, well, I'm sorry, -6, well, that would be y plus 6 squared equals on the other side 2 squared. But we get x plus 5 squared plus y plus 6 squared equals 4. And I'd like to look at those last two. Do you notice that if the center has positive coordinates, my parentheses have subtraction? And instead, if the center has negative coordinates, my parentheses have addition. It's like the opposite. So let's do one more. This time, let's have our center be a point let's say -3, 8, and our radius, let's have our radius be irrational, something like the square root of 13. I'm going to shut up and ask you folks to give me the equation of the circle. Is there anybody else getting in parentheses x plus 3 quantity squared plus in parentheses y minus 8 quantity squared equals 13?
Yeah.
Pretty easy. And the reason we don't multiply them out is because if we're given the equation, it's equally easy to work backwards. Let's say for next examples, I want you to find the center and radius of each circle. So let's say I have in parentheses x minus 9 squared plus in parentheses y minus 1 squared equals, let's say, 36. Well, if I compare that to x minus h squared plus y minus k squared equals r squared. Does everybody see that h, the x value of the center, would be 9? K, the y value of the center, what I'm subtracting is 1. And my radius, well, when I get 36, I must have been squaring 6. Next one, let's say I have x plus 2 squared plus y minus 4 squared equals 7. Well, I have to think that's addition, and my general equation is subtraction. So I must have been subtracting a negative number. So the x value of the center is -2. The y value, what I'm subtracting from y, is 4. And to get 7, my radius, what would I square to get 7? The square root of 7. Is that one all right?
Yep.
And I loosely think if I've got addition, the coordinate will be negative. If I've got subtraction, the coordinate will be positive.
Mm-hmm.
And then one more. Let's just look at x squared plus y squared equals 16. am I subtracting from X here?
1 minus 1.
Do you see a subtraction at all with that X? I'm thinking we're not taking anything away, so the X value will be 0. In the same way, Y squared, well, that's just Y by itself squared. So I'm subtracting 0. And the radius is 4. And in general, if my center is 0, 0, so if my center is the origin, that equation just becomes, whoops, I didn't need that parentheses in. X squared plus Y squared equals R squared. Now, the next one is going to be a little dicier. This time, let's find the center and radius of the circle. And this time I'm going to have X squared plus Y squared minus 10X plus 6Y minus 30 equals 0. And what's happened here is somebody's taken that equation out of general form. Picture if you took one of the ones on the preceding page and multiplied them out. X plus 2 squared would give me a trinomial, and so on and so on. And so what we have to do is we have to put it in standard form. Before we put it in standard form, I want to let you folks know how you should recognize that this is a circle. It's going to be a circle if both X and Y are squared and they have the same coefficient. The X squared and Y squared terms have the same coefficient. So if you've got both variables squared and they both have the same coefficient, usually that matching coefficient, it's nicest if that matching coefficient is 1. So I've got 1x squared plus 1y squared. And that's how I know it's a circle. What we need to do is we need to put it in center radius form. By completing the square. In both X and Y. And I'm looking at the clock. And so I'm going to stop here. I'll upload the notes, but the notes next class, I'm going to just pick up right from where we left off. So we'll put TBC, to be continued. But today we've done a lot. We've found the equations of perpendicular lines. We've found the midpoint of a segment. We've found the distance between 2 points. And we know how to write the equation of a circle. Don't worry about that part where you're completing the square. We'll pick up there next class. Any questions on any of that? If not, we'll see you on Wednesday. Have a great day.
Have a great day.
Bye.